Alrighty, so number one, y'all, they want us to select one of the following sketches that describes the end behavior of the graph. So we're looking at the leading term, and that's the one with the highest exponent. So we got a negative square root of 5, x to the third. So we would use that chart we made that showed the degree, even or odd, and then it showed the leading coefficient, positive or negative. So y'all, what would y'all pick on this one? You got a odd degree of 3, and you got a negative lead coefficient of a negative square root of 5. So A, B, C, D, is it both going down? Is it going to go downhill like B? Are they both going to go uphill like C? Or will it go uphill like D? And y'all on that one, since we got an odd degree of 3 and a negative lead coefficient, it's going to go downhill like B. So you physically got to come in here and write B on that, okay? And then you go to your next. Hey, y'all, I'll write this one out. What I got, f of x equals x to the third minus 15x squared plus 19x plus 20. And they want to know, is 2 a 0? I just want to share my pad. So really, y'all, there's two ways to do this one. But I'm going to do it doing the synthetic way, synthetic division. Now, you could plug a 2 in for everything and see if you get a 0 or not, okay? But since we learned about synthetic division, I'm going to use it. So the first thing I write is my coefficients. 1 for the x cubed, negative 15x squared, 19 for the x, and 20 for the number at the end. I'm going to draw my line and put me a box under there. And the number I'm checking for is 2. So 2 will be my C. So if this is yes, a 0, I better get a 0 remainder. Any other remainder means that that is not a 0, okay? All right, so remember the first number you brought straight down. And then you're just going to multiply and add all the way through. So 1 times 2 is 2. That's going to go into the next column. Negative 15 and 2 give you a negative 13. So now we're going to multiply and get the next column. Negative 13 and 2 is negative 26. All right, 19 and negative 26 give me a negative 7. And then y'all, negative 7 times 2 is a negative 14, which gives me a remainder of 6. So that means no, 2 is not a 0. Now, the other way you could have done this, you could have found f of 2. So you could have put a 2 in for everything. 2 cubed minus 15 times 2 squared plus 19 times 2 plus 20. Work this out. If you get a 0, then it would have been a yes. Any other number, you're going to get a no. Now, we learned that doing substitution like this, I'll get the same answer here that I got over here of that 6. So when I'm done, this should equal 6. So y'all, let's start with the exponents. 2 cubed is 8 minus 15 times 2 squared, which is 4, plus 19 times 2 plus 20. So all I did on that step was the 2 exponents. Now I'm going to multiply. So I got 8, negative 15 times 4 is negative 60, plus 19 times 2 is 38, plus 20. All right, y'all, let's add all that up. We should get a 6 out of that, so let's see. We got 8 minus 60 plus 38 plus 20. And when you push that all in, you get 6. So either way you go, you did not get a 0. So it'll be no for either method, okay? So whichever one you're comfortable at, knock that out. So let's see, I'll go back to Math Lab, and that's just a no. All right, y'all, next question. So let me write this one out. I got f of x equals x to the 6 times x minus 2 squared times x plus 6. Now notice how they want to answer: the smallest zero, middle zero, largest zero. And then we're going to tell their multiplicities. So let me work that on my pad real quick. So the last one don't have an exponent outside the parentheses. So you would automatically treat that as a 1 there, okay? All right, so the multiplicity is going to be a 6 for that one, 2 for that one, 1 for that one. So what we got to do is set the factors equal to 0. So remember the first one, when you set x equal to 0, that automatically means 0 is a 0, and it's going to have a multiplicity 6. Then I set the x minus 2 equal to 0 and solve it. And I'm just going to add 2 to both sides, and I get x is a positive 2. So the 0 of 2 has a multiplicity of 2. And y'all, my last one, set x plus 6 equal to 0. Solve that one by subtracting 6 from both sides. And I get x is a negative 6 with a multiplicity of 1. So my smallest 0 is negative 6. My middle 0 is 0. And then my largest 0 will be the 2. So it's really picky that you put them in like they're wanting on that answer, okay? So I'll go back to Math Lab. Smallest 0, I said, was negative 6, and it had a multiplicity of 1. The middle 0 is 0, and it had a multiplicity of 6. So remember, multiplicity is just them exponents. The largest 0 was 2, and it had a multiplicity of 2. So just make sure you get them in order, okay? All right, y'all, next. All right, the four-term polynomial. So let me write that down. F of x equals x to the third minus 2x squared minus the x plus 2. So they want me to find the zeros and their multiplicities. So y'all, this is the one where we had to factor the four-term polynomial. And the way we did that, we grouped it. We grouped the first two terms, and then we grouped our last two terms. And we're going to factor out a greatest common factor from each little group here. So for the first two, you got an x cubed. This one has the x squared. So the most that they both have would be the x squared. So you're going to factor out an x squared. In parentheses, x cubed divided by x squared leaves you an x minus 2x squared divided out the x squareds leaves the 2. All right, so that's the first GCF and what was left. The second GCF always has the same sign as the third term here. So the second GCF will be negative. And y'all, the only thing these two have in common as a factor would be a 1. So you always got to at least factor out a 1, okay? And so what's going to happen? Negative x divided by negative 1 makes that a positive x. And then 2 divided by the negative 1 makes that a negative 2. Remember, parentheses got to match at this point. So now you form two sets of parentheses. In one set of parentheses, you put the stuff on the outside, the x squared minus 1. And in the second parentheses will be the x minus 2. So we're sort of undoing the distributive property where you would have did x squared times x squared times negative 2. That's this factor. And then the negative 1 times x, and the negative 1 times negative 2 gives you this sort of factor here. All righty, so we're as factored as far as we're going to go at the moment. So I'm going to write some exponents here. Since these parentheses do not have exponents outside of them, they're both going to be a 1. Now here's the thing. That is the x to the third. That means we got to get 3 answers on this. So the first one, you're going to set x squared minus 1 equal to 0. And then you're going to set x minus 2 equal to 0. So y'all, this one's quadratic. So what I'm going to do, since I got the x squared term in a number, I'm going to add 1 here and do my square roots to it. So I'm going to add 1 to both sides. I get x squared equals 1, and then do the square root. Now remember, that's going to give me the x. Square root of a number means you got to put a plus or minus in front of this, because it could be a positive 1 or it could be a negative 1. All right, the next one, add 2. And we get x is a positive 2. So my zeros are going to be 1, negative 1, and 2. Each has a multiplicity of 1. All right, y'all, so that's what we're going to put in there for this question. So let's go find Math Lab. So here we said it was 1, comma, negative 1, comma, 2. And we said that each had a multiplicity of 1. All right, y'all, then you hit next. So this one, they want to know if this statement is true or false. Now, this is talking about whether the zeros, was the graph going to cross the x-axis at a 0, or was it going to come down and be tangent to it? So remember, tangent meant it sort of come down, touches it, and went back up. So they're giving me p of x equals x minus 2 to the 10th, x plus 3 to the 5th. They're saying that the polynomial function y equals p of x crosses the x-axis at 2, 0. Well, the only factor over here that would give you a 0 of 2 would be the first factor, the x minus 2 to the 10th. Remember, if you set x minus 2 equals 0, you would get x equals 2, which is the same as the x-intercept of that point. So since it's coming from that factor, and that factor has an exponent of 10, 10 is an even exponent. And when they're even exponents, that means it comes down and it's tangent to the x-axis. So that is false because it's saying it crosses. So we want to go to the one that says false, and it tells the right thing about the 10. Because see, B says the exponent 10 is odd. Well, that is false. So you want C because it says the exponent 10 is even, thus it is tangent at that point, okay? So get true or false and then pick the one that has the right description of your exponent. All right, moving on. All right, so this is the one where we had to find the maximum real zeros, maximum x-intercepts, and the maximum number of turning points. Well, the maximum number of real zero is equal to the highest exponent. That's a 7. So you're going to put a 7 in there. The maximum number of x-intercepts is the same thing as the zeros, and that's going to equal the highest exponent, which was a 7. The one that is different is the maximum number of turning points. It is going to equal the highest exponent minus 1. So highest exponent is 7, minus 1 would make that 6. So these will always be in this form, 776, 554, 887, okay? The third answer will always be one less than the first two. All right, y'all moving on. Number 7. All right, so this is basically going off our leading term test again. We got a 1/3 x squared. You got an even exponent of a 2 and a positive lead coefficient. So this is going back to that end behavior chart, okay? So if you got an even degree of 2 and a positive lead coefficient, both sides are going to go up. And y'all, only one graph has both sides going up, and that would be C, okay? So remember, even exponents either went up or down. Odd exponents went uphill or downhill, okay? And y'all, this is basically the same thing. They're just giving you more of a graph look about it. But A is going uphill left and right. B is going downhill. C, both sides are going down. And D, both sides are going up. So let me make them all a little bigger here. So the leading term is that negative x to the fifth. You got an odd degree of 5, a negative lead coefficient. So when it was an odd degree and a negative lead coefficient, that thing went downhill left to right. And y'all, the only graph going downhill is B here. See how it sort of goes downhill, got a hump and then goes downhill. Okay? So really, these few graphs here were basically going off of our chart that we made, okay? All right, so this one, I would probably actually graph this one. So I got g of x equals negative x minus 2 squared, and then x plus 3 squared. Now look at this graphs here. All these graphs, if you look at all these graphs, they're going from negative 10 to 10 on the x's and from negative 100 to 100 on the y values, okay? So I'm going to set my calculator to match that, okay? So let me share the calculator this time. All righty, y'all. So I'm going to go to y equals, I'm going to put that in, negative x parentheses, x minus 2, close parentheses, and square that, and then parentheses, x plus 3, close parentheses, and square that. I'm going to go to the window. Okay, so the x's are at negative 10 and 10 like I needed. So I'm going to go to the y minimum. The y minimum was a negative 100. The y maximum was a positive 100. And then it looked like the y values were going by tens, 10, 20, 30, 40, and so on. So you're going to put that in, and you're going to hit graph. All right, so look here, it's going downhill left to right. On the left side, it's coming down and touching negative 3. Then it goes up through the center, and then it comes up and touches positive 2 and goes down. So it's touching on the left side at negative 3, the right side at a positive 2. All right, y'all, so I want the graph going downhill. So it's either going to be B or D here. So the thing about it, you got to be really careful and zoom them in a little bit. So on B, see how it's touching the negative 3 on the left side, and then it's touching under the 2 on the x-axis on the right side? That's one we need. If you look at D here is touching at negative 2 on the left side, and it's touching over there at positive 3 on the right side. So you want to go with B on that one, and then hit next. All right, y'all, so I'm going to do the same thing here. So these ones are going from -5 to 5 on the x's and -250 to 250 on the y values. And it's f of x equals 6x cubed minus 4x squared minus 54x plus 36. Now, we'll tell you, it's an odd degree with a even lead coefficient of being a positive. So since you got a positive lead coefficient and an odd degree, it's going to go uphill left to right. So it's either going to be A or B. So let's go graph it and see which one we get. So I'll go y equals and clear that out. All right, so I had 6x to the cubed, arrow right and come back down, minus 4x squared minus 54x plus 36. All right, so let's just graph it after we set our window from -5 to 5. And those went by ones, and then this was like a -250 down to a positive 250. And I'm going to leave that going by tens. All right, y'all, let me look. They might have went by. Let me go back to the math lab and see what it looks like they're going by. Okay, those are going by 50, so I'll set my window to match that. So on the Y values, it looks like they're going by 50s every mark. And y'all's are going to be similar to this, so y'all's will be -5, 5, 1, -250, 250, and 50 on the Y scale. The scale is how much it's going in between each of the marks. All right, look at that. It's a little above the origin in the middle. So it don't go through the origin. It's a little bit above it. So if you look at A and B here, A is going right through the middle of the graph in the origin. So y'all, it's got to be B on that one. See how it's a little bit above that origin there, okay? So be careful and use their scale so that you can see that. All righty, y'all. So now we're starting to do our foiling. They're giving me a -1, 2, and -6. And they want me to find the polynomial of degree 3 that has the following zeros. Now look, they're giving me most of the answer. X cubed plus blank x squared minus 8x minus 12. So everything should match that. All we're looking for is what number will we put in that box, okay? So y'all, this is where we foiled. I had these three answers. So I set it as x equals -1, x equaled 2, x equaled -6. I'm going to get zeros on the right side by adding 1 to the first one. So you're basically moving the numbers to the other side and changing their sign. Here you would subtract 2. X minus 2 equals 0. Same thing, move it over, change its sign. And then the last one, I would add 6. And get x plus 6 equals 0. At this point, we put them all in parentheses. So we're working totally in reverse of what we would do if we were multiplying, okay? We're going in reverse and factoring, okay? So now I'm going to FOIL these two together and I'm going to bring down the x plus 1 in the front. So these two I'm going to do on the side. X minus 2 times the x plus 6. Once I get this answer, I'll put that into parentheses, okay? All right, y'all, so right here, x times x is x squared. X times 6 is 6x. -2 times x is -2x. -2 times 6 is negative 12. Add the like terms in the middle. 6 minus 2 will leave me a 4x, and then minus my 12. So I'm putting that right here. X squared plus 4x minus 12. All right, so you multiply them two together. Now we got to multiply all this together. So I'll just multiply it here. This x multiplies by all three of those, and then we're going to take the 1 and multiply by all three of those. So x times x squared is an x cubed. X times 4x is a 4x squared. X times negative 12 is a negative 12x. Now multiply to 1 times x squared is 1x squared. 1 times 4x is 4x. 1 times negative 12 is negative 12. Now at this point, all you can do is add like terms. So bring down your x to the third. So the x squareds will add together. 4 and 1 makes 5x squareds. The x's will add together. Negative 12 and 4 is a negative 8x. And y'all, at the end is our negative 12. So it looks like the only number that answer wanted was that 5. And then everything else should match up, the negative 8 and the negative 12 on that one, okay? So you're just doing a lot of foiling, okay? All right, y'all, so let me go find that out and put that in Math Lab. And like I said, everything matches up, so all we had to do is put a 5 right there. And y'all, you know what? This is the same thing here, but they're giving me the radical stuff, okay? So let me write them down. Square root of 2, negative square root of 2, and 5. And remember, anytime you do radicals, they always came in conjugate pairs. So that's why if you got a square root of 2, you're going to have a negative square root of 2. Now, we got 3 zeros, so it's going to be one of these answers with an x cubed. The x4 is not going to be one of the answers because we don't have 4 zeros, we just got 3, okay? So it's either going to be A, C, or D. So y'all, let's go start foiling this out. Alrighty. So usually when I do these, I put the numbers first and then the radicals. So I'm going to put my x equals 5, x equals square root of 2, x equals a negative square root of 2. And I'm going to do the same thing I did on the last problem. I'm moving everything over by changing their signs. So add negative 5 to both sides. X minus 5 equals 0. Subtract the square root of 2 from both sides of the middle one. X minus square root of 2 equals 0. And y'all, the last one, we're going to add the square root of 2 to both sides and get x plus square root of 2 equals 0. All right, so we got everything set to 0. Now we're going to put everybody in parentheses. All equal to 0. So y'all let me go to the side. Because what I'm going to do, I'm going to start out by multiplying them two. So I'm going to bring down to x minus 5. It'll multiply by whatever I get out of this. So the x minus square root of 2 times the x plus square root of 2. So x times x is the x squared. X times square root of 2 is a positive square root of 2 times x. Then I got a negative square root of 2 times x. That's going to be a negative square root of 2 times x. And then finally, a negative square root of 2 times a positive square root of 2 is a negative square root of 4. So since the 2's under a radical and the 2's under a radical, they can be multiplied together and get a 4. But y'all remember, we know what that's going to give me because a radical times itself always gives you the number under the radical. So that square root of 4 is going to turn into a 2 in a second. These in the middle, they cancel. Square root of 2, negative square root of 2, those x's cancel. So all that's left is our x squared minus the square root of 4, which is 2. So y'all, I'll put that here. X squared minus 2. So the last step was to come in and actually FOIL this out, okay? So I'll just FOIL it right here. So x times x squared is an x cubed. X times negative 2 is negative 2x. Negative 5 times x squared is a negative 5x squared. And then finally, the negative 5 times negative 2 is a positive 10. Y'all, the only thing I would do to that is rearrange the middle because they're out of order. So bring down your x cubed minus the 5x squared minus the 2x plus the 10. All right, so that's what we're looking for. X cubed, negative 5x squared, negative 2x plus 10. Whoo, y'all, that's a lot of fooling on them two problems. All right, x cubed minus 5x squared minus 2x plus 10. So let me see. Oh, look at that. C is close, but they got the 2 and the 5 backwards, okay? So watch out. They try to do little tricks like that. We need D. X cubed minus 5x squared minus the 2x plus the 10, okay? Alrighty, y'all, this one. They're telling me I got a degree 4 polynomial. So that means you need 4 zeros. Well, they're giving me some of the zeros. I is one of the zeros, and 6 minus square root of 13 is the other zero. So they want me to find the remaining zeros. Well, we know one thing. The imaginary zeros come in conjugate pairs. So if I is a zero, negative I is also a zero. So put in a negative I, comma. Now, if 6 minus square root of 13 is a zero, that means 6 plus square root of 13 is also a zero. So this one was just knowing that these kind of zeros came in conjugate pairs. I and negative I, 6 minus square root of 13, 6 plus square root of 13. Remember, you don't change the sign of the 6, only the radical part, okay? All right, y'all, so then we hit next. So this, since we now know that these zeros come in conjugate pairs if they're imaginary, they're giving you a negative 4i zero and a positive 2 zero. And they want me to come up with a polynomial. So y'all, that means we're doing more foiling. But the thing on this one, they're only giving me part of my zeros. But we know this. If negative 4i is a zero, then a positive 4i must also be a zero. Okay, so if they give you imaginary, its conjugate pair will have to be a zero also, okay? So, let me set up my answers. I'm going to put my number 2 first. I always like to keep my imaginary stuff and my radical stuff together. So here's a x equals negative 4i, and then x equals a positive 4i. And y'all do like we did the 2 questions ago. Get zeros on the right side by subtracting and adding. So I get an x minus 2 equals 0. Here I'll add 4i. X plus 4i equals 0. And on this one I'll subtract 4i. and x minus 4i equals 0. So after this chapter, you got good at FOILing for sure. Put everything in parentheses. All equal to 0. And so guess what? Since I put these two together, I did that for a reason, because I want to start with them two when I'm FOILing, okay? All right, so let me do that on the side. X plus 4i times x minus 4i. Now remember, these are conjugate pairs, so the I stuff is going to disappear in a second. So let's start out. X times x was x squared. X times negative 4i is a negative 4ix. All right, y'all, you got a positive 4i times x. That's going to give me a positive 4ix. And then a 4i times a negative 4i is a negative 16i squared. So y'all notice, negative 4i, positive 4i, the x's in the middle cancel. So let me ask y'all this. What does this I squared equal? Do y'all remember that? Oh, good job, Mackenzie. I squared equal negative 1 here, remember? So technically, you're going to replace I squared with a negative 1. So that negative 1 times that negative 16 is going to make that a positive 16. So I end up with my x squared plus 16, okay? So once you turn that I squared into negative 1, you're multiplying them. Negative times negative is a positive. So over here, bring down to x minus 2, and then put in our x squared plus 16 that we got when we FOILed those. All right, y'all notice this now. I'm going to multiply this stuff by FOILing. So let's see what we get. X times x squared is an x cubed. X times 16 is a 16x. Negative 2 times x squared is a negative 2x squared. And then that negative 2 times 16 is a negative 32. So y'all, what are we going to do? We're going to rearrange the middle. So we get an x cubed minus the 2x squared plus the 16x minus the 32. All right, y'all. So let's see. I forgot how MathLab wanted us to put that. I don't think they gave me an A, B, C, D choice on that one. So I think we actually got to put in the polynomial. Now we don't have to put in the equals 0. We just got to put in the x cubed. So let me do this. X cubed, arrow right, minus 2x squared, arrow right, plus 16x, and then minus 32. So y'all just put the polynomial in there. We don't have to put anything else on that one, okay? And then check your answer. All right, y'all, so let me write this one down. So they're giving us P of x equals x to the fourth plus 16x squared minus 225. They're telling me 5i is a 0. Find the remaining zeros. So since that's an x4, they gave me 1 0, so I need to find 3 more zeros, okay? All right, so the first thing we got to do, this is where we did a lot of synthetic division. So we start with the first zero they're giving me, 5i. and we're going to do synthetic division and divide this 0 out and see what we got left, okay? Now remember, you need to write the coefficients, but y'all, I got a 1x4 here. I do not have an x3 term there. So since I don't have an x3 term, I need to put a 0 for the placeholder. I got a 16 for the x squared. I don't have an x term sitting here, so I need to put a 0 for it. And then at the end is a negative 225. So you got to have every placeholder represented. So 1x4, 0x cubes, 16x squared, 0x's minus 225. Now, since they told me 5i is a 0, when we do our synthetic division, we better get a 0 right here, okay? So we got to get a 0 since that is a 0. So y'all, here we go. Bring the 1 down. 1 times 5i is 5i. 0 plus 5i is 5i. Now watch this. 5i times 5i is 25i squared. Well, y'all, I squared equals negative 1. So 25 times negative 1 makes that a negative 25. Then y'all watch this. If you're weak at multiplying the i's times each other, you got a calculator here. So watch this. Let me quit the graphing. All right, here's a 5. To get the I above the decimal, you hit the second button and the decimal. Times 5 second decimal. So watch this. 5i times 5i was negative 25. So you can multiply i's times themselves on the calculator, okay? All right, y'all. 16 and negative 25 is a negative 9. Negative 9 times 5i is a negative 45i. 0 plus negative 45i is a negative 45i. And then finally, that negative 45i times 5i. So watch this. Go to the calculator. Negative 45 second decimal times 5 second decimal for the I. Enter, I get 225. Well, guess what? Negative 225 equals 0. So since we still got 4 numbers here, this would be like a x cubed, 5i x squared, minus 9x, minus 45i. These coefficients start 1 degree less than the original. So since that was an x4, this would technically be an x3 now. But y'all, all we got to do is write the coefficients because we're still going to do synthetic division. So bring down the 1, the 5i, the negative 9, and the negative 45i. So let me see if y'all remember. They only gave me 1 0 here. Now I need to get this down to 3 numbers before I can do my quadratic formula stuff. So, or my quadratic equations, ever how you want to solve them. But, I need another 0 to try. So what 0 would I try next? Negative 5i, that's perfect. Because remember, 5i, negative 5i, they got to come in conjugate pairs. So the remaining zeros, I know for sure negative 5i is one of those. So when we go through here, we should get a 0, okay? So bring the 1 down. 1 times negative 5i is negative 5i. We all look at that. 5i, negative 5i. Give me 0. 0 times negative 5i is 0. Negative 9 plus 0 is negative 9. And y'all look here. Negative 9 times negative 5i is a positive 45i. So these two will add and give me a 0. So we are right on that and being a 0 because we got a 0. Now what I do now with this one is now 1 degree less than this polynomial would have been. So if this would have been my x cubes, since I only got 3 numbers there, this is my x squared term, my x term, and my number term here. So this is saying that I got an x squared minus 9. I'm going to set that equal to 0 and solve this for my last 2 zeros, okay? And the easiest way to solve this one, when the x term in the middle is a 0, if you got an x squared term in a number, get the number over here and do a square root. So I'm going to get the number over there by adding 9. I get x squared equals a positive 9. I'm going to do square roots to both sides. So that's going to give me my x. Now remember, square root of a number will be a plus or minus. And y'all, square root of 9 is a 3. So my last 2 zeros are 3 and negative 3. We do not put the 5i because that one they gave us. They just wanted the remaining zeros, okay? All right, y'all, so I'm going to go put them 3 answers in MathLab. So let's see, what do we get? A negative 5i, comma, 3, comma, negative 3. All right, so you put 3 in out of the 4 altogether, okay? All right, y'all, next. All righty, so it looks like we're getting into vertical asymptotes. So they're giving me f of x equals x squared plus 5x minus 14 over x squared minus 2x minus 8. All right, so vertical asymptotes come in the form of an equation. X equals a number. It's always x equals a number on vertical asymptotes, okay? And to find them, you set the denominator equal to 0. We're only concerned with the bottom, okay? So you would set x squared minus 2x minus 8 equal to 0. I'm going to solve that by factoring, but you could use the quadratic formula, or you could graph it, remember. If you graph it, you're looking for the x-intercepts where it crosses the x-axis. All right, also I'm going to factor. X squared is an x and an x. The last number is negative. Anytime this last number is negative, you're going to have unlike signs. One factor is positive, one factor will be negative. Now, since it's negative, I want factors of 8 that subtract to give me 2. So 8 is 1 times 8 and 2 times 4. So the ones that will give me a 2 is 4 minus 2, okay? Now what you do, the larger factor, 4, will have the same sign as the middle. So the 4 will be negative and the 2 will be positive. Remember, larger factor always has the same sign as the middle, okay? Now, y'all, I'm going to show y'all. I'll show you how you can factor this also on a calculator. So for me, now that I got it factored, I got to set each factor equal to 0 and solve it. So the first one, I'm subtracting 2 and get x is at negative 2. This one, since that's minus 4, we would add 4 to both sides and get x equals a positive 4. See, this is working backwards from those polynomials we did a while ago by FOILing everything. All right, y'all, so notice I get negative 2 and a 4 on that, right? So watch when I do this on the calculator. I'm going to go to y equals, clear that. I'm going to set my calculator back to a 10 by 10 by hitting zoom and going down to number 6. Zoom 6 and standard, if you hit enter there, it gives you a 10 by 10 calculator graph back, okay? All right, so let me go here, and let's now do our problem. Now, I'm only worried about factoring the bottom, so I had an x squared minus 2x minus 8. Now, I'm not graphing the whole function they gave me. I was only finding the vertical asymptotes by factoring that bottom. But remember, graphing will show you the x-intercepts, which is the same as finding those answers, okay? And y'all watch this. Look here, the left side is crossing over here at -2. Well, that was one of my answers. And if you count on the right side, 1, 2, 3, 4, the right side is crossing the x-axis at 4, 0. So you still could get -2, 4 if you wanted to graph it, if you're sort of don't like factoring, okay? All right, y'all, let me go to Math Lab. Now remember, x equals -2, x equals 4. A is wrong because they put y there. So do not pick the one with the y. You got to have the x's, okay? All right, y'all, then we hit next. So this one is a domain. F of x equals 2 over x squared minus 2x minus 35. And y'all, what's nice about this? They want the domain in interval notation. Um, but what's nice about this is in the domain, we're only going to kick out numbers that make this undefined. So we pretty much do this the same way we did these vertical asymptotes. We're only concerned with the bottom of this fraction, okay? And it cannot equal 0. So that means we'll set it equal to 0 and solve it to get our numbers. So it's going to be parentheses again. X squared is an x and an x. The last number's negative again. So I got one positive and one negative. So then I need the factors of 35. You got 1 and 35, 5 and 7. So it's only two ways to multiply to get it. And I need the ones that'll subtract and give me 2. So that's going to be 7 and 5. The larger number 7 will have the same sign as the middle. So the 7 will be negative and the 5 will be positive. So if you went to y equals and graph x squared minus 2x minus 35, and when you graph it, look at the x-intercepts. The x-intercepts will give you the same thing as these two answers I'm about to get. So this one I'm going to subtract 5, and this one I would add 7. So if you graphed it, you would get it crossing over here at -5 on one side, and it would cross at the +7 on the other. Now, y'all remember, this one wants the domain in interval notation. So we're going to kick these two numbers out of my domain. So I'm going to start with -infinity. The first number we would hit would be -5. Union around that -5 until we hit 7. Union around that 7 till we hit positive infinity. So this is what you would have to put into your math lab. So let me find my parentheses. Parentheses, -infinity, comma, -5, close parentheses, union, open parentheses, -5, comma, 7, close parentheses, union, open parentheses, 7, comma, positive infinity, and then close parentheses. Okay, so put it in interval notation on that answer. All right, this one wants a horizontal asymptote. I got a 2x to the third plus 5 over a 3x to the third minus 5. So y'all let me explain this one a little bit. When we did horizontal asymptotes, there was 3 cases. the exponent on top was greater than the exponent on the bottom, the exponent on top was less than the exponent on the bottom, or the exponent on top was equal to the exponent on the bottom. So you're looking at the biggest exponents. So the exponent on top is a 3, exponent in the bottom is a 3. So they're equal. So the top degree equals the bottom degree. So that means now the horizontal asymptotes are going to be y equals a number. Well, remember, y equals a over b. A is going to be the 2, b is going to be the 3. So remember, it's always the top over the bottom. If there wasn't a number there, I'd have used a 1 for these, okay? But I do have numbers here. So the top one would be a 2, the bottom would be a 3. So if they're equal, you're looking at the numbers in front for your horizontal asymptote. So I'm looking for one of those to say 2/3. Well, we probably got to put it in. Now look here, they got the y equals, so we're just going to put in the fraction and put in a 2 over 3 for that, okay? All right, y'all, let's hit next. All right, y'all, so let me write what I got. F of x equals 2x plus 2 over x. So they want the domain. Um, Really, they want x, the domain, x-intercept, y-intercept. Now it says that asymptotes, but really, you don't have to put them because we're going to graph these and see which one of these 4 pictures we get, okay? So I'm just going to find what they want, and then we'll graph it to see what we got left. Okay, so for the domain, I'll start with that. For the domain, I'm going to set the bottom equal to 0, which means there's nothing else you can do that. So we're going to kick out 0 from our domain. So my domain will go from -infinity to the 0, union 0 to positive infinity. Okay? So I'm only kicking out one number, 0. My x-intercepts, you find the x-intercepts by setting the numerator equal to 0. So this will tell me where it's going to cross the x-axis at, okay? So to solve that, I'm going to subtract 2. 2x equals -2. I'm going to divide both sides by 2. So I get x equals a -1. So that means my x-intercept is -1 for the x, 0 for the y. To find my y-intercept, I would find f of 0. So I would have 2 times 0 plus 2 over 0. Well, y'all look at that. You got a 0 in the denominator. This thing is undefined. Since this is undefined, that means there is no y-intercept. Well, that makes sense because we told it we had to exclude 0 from our domain anyway, okay? So, no y-intercept on that one. So let's go plot that and then we'll graph it, okay? All right, so -infinity, 0, 0, positive infinity. So we had A for our domain. We had an x-intercept. Now the x-intercept has to be an ordered pair. So parentheses, -1, comma 0, close parentheses. Now we said we don't have a y-intercept because that thing was undefined. So now we got to choose a graph. So let's go to the calculator and graph this. So we'll go y equals, clear everything off. Since it looks like a fraction, I'm going to hit the green button, the y equals, and enter to get my fraction notation. On top was a 2x plus 2. On bottom was an x. All right, y'all, so let's see. We just want to what? Look at the graph. And it looked like all those graphs were 10 by 10 like I'm set at. So I'm going to hit graph. So look, your left side comes down at that -1 and heads downhill towards negative infinity. The right side on the other side of 0 for the x-axis, the y-axis comes down. And if you notice, it's leveling it out about where that horizontal asymptote would be on this one, which would have been a 2. So yeah. So okay, I want the one going down on the left, crossing at -1. So let's find that graph. Y'all, I think I'm going to go with D here. So you see D's coming down that left side, crossing over at -1. And then that little dotted line they're trying to approach, that looks like about 2. And if you look at the horizontal asymptote, since they had a degree 1 on top and a degree on bottom, the horizontal asymptote would have been that 2/1, which is 2. So if you wanted to find that the horizontal, just to help a little bit on that, you could have done that. But definitely D on that one, and then go to next. Now this one is the same thing, but look at this. Let me write this down. F of x equals x squared plus x minus 6 over x squared plus 5x plus 6. So we want domain, x and y intercepts. Now look at this one. It wants asymptotes. Now remember, on the one down here that says oblique asymptote, click B on that one because you will not have an oblique asymptote, okay? And then let's see, they want us to pick one of the 4 graphs for that one also, okay? So same as the last one, except they're giving me a little more work on this one. So y'all, let me start with my domain. For my domain, I'm going to set the bottom equal to 0. And I'm going to factor it to solve it. So on this one, x squared is an x and an x. The last number is positive. Anytime the last number is positive, both of these factors will have the same sign as the middle. So they're both going to be positive. And then I'm looking for factors of 6 that'll add to give me a 5. So for 6, you had 1 and 6, 2 and 3. So y'all's going to be 2 and 3 for that. So now to finish out, set both these equal to 0. So y'all, the first one I would subtract 2. And then this one I would subtract 3. So if you wanted to graph just the bottom of this, remember, you could graph the bottom of this in y equals and look for the 2 x-intercepts. You would have had one at -2 and at -3, okay? All right, so my domain for this is -infinity to -3, union -3 to -2, union -2 to positive infinity. Make sure these numbers go in the right order. All right, so that's the domain. X-intercepts. X-intercepts, I'm going to set the top equal to 0. All right, so that one I'm going to factor. Or you could graph this part in y equals and get those 2 answers that way, okay? All right, x and an x. Remember, last one's negative, so I got one positive and one negative. This time, my larger number will be positive because it's positive in the middle. So what factors of 6 will subtract and give me 1? Well, that's over here. I got factors of 6 already. That'd be 3 and 2. 3 would be positive. 2 would be negative. All right, so finish it out by solving these. So y'all here, I would subtract 3. I get x is a negative 3. Here I would add 2. Get x is a positive 2. So my x-intercepts are going to be negative 3, 0, and 2, 0. But y'all, here's where the fun start happening. Remember, I can't have a x-intercept at negative 3 because my graph is undefined at negative 3, right? So since my graph is undefined at negative 3, it's going to cancel out that x-intercept and put a hole in the graph. That means when you find your two vertical asymptotes, that one vertical asymptote, if it equals x equals negative 3, we got to cancel that out also, okay? All right. So that's the x-intercept. Let's find the y-intercept. Y-intercept is f of 0. So put a 0 in for all the x's. 0 squared plus 0 minus 6 over 0 squared plus 5 times 0 plus 6. Well, if you notice, the zeros cancel. They're all gone. So I end up with a negative 6 over 6, which is a negative 1. So my y-intercept is 0 for the x, negative 1 for the y. All right, vertical asymptotes. Vertical asymptotes, I found them by setting the bottom equal to 0. Well, I've already done that when I found the domain. So the vertical asymptotes would have been the x equals negative 2, x equals negative 3. Remember, these are going to match the domain stuff, except for one thing. We said if we got an x-intercept that matches a vertical asymptote, it cancels out the vertical asymptotes. So at negative 3, it's just going to put a 0 in the graph, okay? So y'all, on this problem, you will have one cancel, okay? So that negative 3 from the x-intercept cancels that vertical asymptote. So the only vertical asymptote we'll have is the x equals negative 2. All right, what about a horizontal? Horizontal, the degree on top matches the degree on bottom. So the top degree equals the bottom degree. When they're equal, y equals a over b. Well, there's no numbers in front of these, so you would treat it like a 1 over 1. And y'all, 1 over 1 is basically a 1. So my horizontal asymptote will be y equals 1. Vertical asymptote, x equals negative 2. All right, so let's go put all this in. So the domain we said was parentheses, negative infinity, comma. I would hit negative 3 first, union around that negative 3 to comma negative 2, union around that negative 2, comma, and then you're heading off towards positive infinity. All right, so let's see what this says. The x-intercepts are the y-intercepts. Well, I did have an x-intercept, So right here, x-intercept was 2, 0. The y-intercept was 0, comma, what was that? And the y-intercept, -1. All righty. The vertical asymptote is x equaled. Remember, we kicked out the -3, so the only one left was the x equals. What am I looking at? Vertical asymptote, x equals -2. There we go. The horizontal asymptote we said was y equaled 1. There was no oblique. So now we just need to pick a number. Now, if you look here, the graph's got those zeros on those at that -3, remember, okay? All right, y'all. So let's go to the calculator and let me show you how I would graph that. So y equals, clear that off. So I want it to look like a fraction. So alpha y equals enter. On top, I had an x squared plus x minus 6. On bottom, I had an x squared plus 5x plus 6. All right, so I'm wanting to see what the graph looks like, so hit graph. All right, y'all, so there you go. The left side sort of coming down. The right side is crossing at that uh, -1 for the y-intercept. And as I go to infinity, it's trying to approach that 1 for the horizontal. Whew, so all right, y'all, let's try to match that picture. Y'all, if I ain't mistaken, I think it's D here, right? D sort of goes up. See, it's got a hole in the graph where that -3 would have been, that x value. The right side is coming up, crossing the y-axis at -1, and then trying to get to my asymptote. All righty, y'all, let's see what 21 has in store. So this one is really graph heavy on this last part of this one, okay? Um, I think this is the last one, and then it starts getting into let me see who was iPhone am I there. It'll get into the inequality stuff. So same thing here. Domain, x and y intercepts, vertical, horizontal asymptotes, okay? All right, so first I'm gonna do my domain. So I'm gonna set the bottom equal to 0. Solve that by subtracting 3. And we get x is a -3. So we're kicking -3 out of our domain. So negative infinity to -3. Union around -3 to positive infinity. So only one number we got to kick out on this one. All right, the x-intercepts, we set the top equal to 0. So let me solve that. I get x equals 7. So that means the x-intercept is 7, 0. Y-intercept, we find f of 0. So that's putting a 0 in top. 0 minus 7. 0 plus 3 on the bottom gives me a -7/3. So that means the y-intercept is 0 for the x, -7/3. All right, vertical asymptote. Well, I find those the same way I found my domain. So if it's undefined at -3, that means my vertical asymptote would be x equals -3. See, nothing cancels this time because the top had numbers different than this bottom, okay? What's left? Horizontal asymptote would be y equals, well, y'all got a degree 1 on top, degree 1 on bottom. So once again, the degrees are equal. So I'm looking at these numbers in front of the x's, which are ones, since there's no number there. So it's going to be 1 divided by 1 again, which is 1. Okay? All righty, y'all. So let's go put that in, and then we'll look at this graph. All right, so my domain was parentheses, -infinity, comma, -3, close parentheses, union, open parentheses, -3, comma, positive infinity. All righty. Let's see. I had a y-intercept and an x-intercept. So let's go to the one we want B on that one. The x-intercept we said was 7, 0. Make that look like an ordered pair. The y-intercept is 0, comma, and we got a -7/3. So that'll be -7 on top, 3 on the bottom, arrow right, and then close your parentheses. All righty, let's go down. Horizontal asymptote would be A, x equals -3, we said. Horizontal asymptote, we did, and we said that was y equaled 1 over 1, which equaled 1. Remember, there's no oblique on these. All righty, so I had a vertical asymptote at -3. So A has one at -3, it looks like. B has one at -3. And then C and D are at +3. So it's either got to be A or B. Now the difference is A has the y-intercept crossing at a positive number. But my y-intercept was a negative number. So it's got to be B. So let's go graph it just to make sure. So y equals, I'm going to clear that off. Alpha y equals to get my fraction, enter. All right, so on top was x -7. On bottom, x plus 3. All right, I'm going to hit graph. And y'all see mine crossed on the bottom side on the y-axis. So that was it. I think that was what, B on that one? And that was B, okay? All right, so I think the rest of these are just solving inequalities. So let me write this one down. X -4, x plus 1, less than 0. Now we'll say on these inequalities, remember, so recall, if it's less than or greater than, use parentheses around the number. If it's less than or equal or greater than or equal, you're going to use brackets around the numbers, okay? Now, this one's already factored, so take both of these factors and set equal to 0. So this one I would add 4. I get x equals 4. This one I would subtract 1 and get x is a -1. So remember, this is where I set up a number line. So let's see, -1 would be on this side, 4 would be on this side. And I pick a test point. So for me, I always test 0. So I know 0 is in between -1 and 4 on this number line. So I'm going to test 0. If it's true, I'm going to shade it. If it's false at 0, I'm going to shade the outside. So put a 0 in for these x's and see if this is true. 0 minus 4 times 0 plus 1 has to be less than 0. Well, this gives me -4 times 1 less than 0. So -4 less than 0. That is definitely true. So since that's true, I would shade my number line right in the middle. I would shade it in between since it's true for where the 0 was at. Now, I'm going to write my answer in interval notation. Now, when it's in the center, my numbers will go from -1 to 4, and that's it. Now I got to determine if I'm going to use parentheses or brackets around the number. Well, that's less than, and right here, less than uses parentheses. So this answer would be -1, comma 4 in parentheses. All righty, so let's go put that in. And they're all wanting interval notation. So -1 to 4 on that one, you're going to hit next. All right, y'all, this one has x squared minus 17x plus 66 greater than 0. So for me, I'm going to solve it by factoring. Okay. And when I solve them, I always set them equal to 0 to get my numbers. So x squared is an x and an x. The last number is positive. So since the last number is positive, both of these factors will be negative like the middle number. And what I'm looking for on this one are factors of 66 that'll add and get 17. So break down 66. 3 and 22, 4 don't work, 5 don't work, 6 and 11, 7, 8, that's all. So one of these adds to get 17, and that would be 6 and 11. All right, now set both them equal to 0 and solve. So y'all, my first one, I'm going to add 6 to both sides. Our second one, we're going to add 11 to both sides. So here's my number line. It's 6 and 11. Now me, I'm still going to test 0. So 0 is before 6. So that means 0 is over here somewhere. If it's true for 0, I'm going to shade the first section and the last section. They always go together. If it's false for 0, I'm only going to shade the middle section, okay? All right, so let's see what we got. 0 squared minus 17 times 0 plus 66 has to be greater than 0. Well, that's 0. That's 0. So 66 greater than 0 is true. So since that's true on my number line, I would shade where the 0 was located. And by default, I also got to shade the last section. All right, let's notice we had greater than, so we're going to use parentheses around the number. So we go from -infinity until we hit 6, union. We don't go from 6 to 11 because that was all false. We got to start where it shades again, and that's at 11 to +infinity. Remember, you do not write 6 to 11 in the interval because that was false. It's false where we didn't shade it, okay? All righty, y'all. So we would put that answer in. So let's see, parentheses, negative infinity, comma, 6, close parentheses, and then union parentheses from 11, comma, to positive infinity, close parentheses. All right, y'all, let's see what they got next. All right, so this one has 4 minus x squared is less than or equal to a 0. Y'all, this one is the trickiest of these. You gotta be really, really careful on this one. Okay. Now I'm going to leave this in here until I get this x squared to be in positive, okay? So first thing I'm going to do is move the 4 over by subtracting 4 from both sides. So that cancels. I get a negative x squared less than or equal to a negative 4. Now we need the x squared to be positive, so we're going to divide by this negative 1 on both sides. And y'all, it is very important since we're dividing by this negative, y'all got to reverse that inequality and make this a greater than or equal. So reverse the inequality since we divided by a negative. We don't switch it when we divide it by positive numbers, only negative numbers, okay? So that gave me an x squared greater than or equal to a positive 4. This is going to determine my true or false when I put a 0 in, okay? I'm going to use this one when I test 0. All right, now to solve this, I'm going to set x squared equal to 4. I'm going to take square roots of both sides. So square root of x squared is x equals a plus or minus square root of 4, which is 2. So your number line for that one will be a negative 2 and a positive 2. 0 is right in the middle. So I'm going to test 0 using this equation, y'all. So put a 0 in for the x squared. So 0 squared greater than or equal to 4. Well, that's 0 greater than or equal to 4. Y'all, that is false. 0 is not greater than 4. That is false. Since it's false where 0 is, that means you got to shade the outer edges on that. Okay? All righty. If that would have been true, I would have only shaded the middle, okay? Now notice, this has equals, so I'm going to use brackets on my numbers. So this is shading in from negative infinity to a negative 2, bracket, union, bracket, positive 2 to positive infinity. Remember, infinity always uses curvy parentheses. The numbers are what's going to use the parentheses or the brackets, okay? Based on that inequality symbol. All right, y'all. So this one I would have curvy parentheses, negative infinity, comma, negative 2, bracket, union, bracket, 2, comma, positive infinity, and then parentheses. Okay, so just make sure you remember those brackets when you got the equals. All right, y'all, our last question. X squared plus 13 less than 4x. All righty, so let's go work that one. Y'all, so the first thing I'm doing, I need this 4x moved over. So I'm going to subtract 4x from both sides because I need a 0 over here. So I got an x squared. I'll put the negative 4x. Then I'll put my 13. All that has to be less than 0. All right, so now I'm going to factor it and set it actually equal to 0 when I factor it, okay? X squared is an x and an x. This last number's positive again. Since the last number's positive, both factors will be negative like the middle. So anytime that last number's positive, you got to have like signs, okay? All right, so let's see. I need factors of 13 that'll add to get a 4. We all 13. The only way to get that is a 1 times 13. Well, 1 and 13 does not add to get me a 4. So since I don't have any numbers that'll add to get that middle number, this one does not factor. Since this does not factor, that means it is a no solution. And you got to use that no solution symbol in MathLab, okay? So I would go to MathLab. And when you click in the box down here, right by more, it says empty set. That's what we use for the no solutions. So click that. It'll put it in there, and then you can submit your test. All righty, y'all. So let me stop that share. All righty, y'all. So questions on that. Now, I was going to do 9-1 today, but I'm deciding I'll do 9-1 and 9-2 tomorrow. Um, Thursday, I'll do 9-3 and 9-4. Friday, I'll do 9-5. Then I move 9-6 to next Monday. We'll do 9-6 and 9-7 together that day. And then that Tuesday, we'll review for test 4. That Wednesday of next week, we're going to start reviewing for the final exam, okay? So, y'all, it's getting close to being over. Y'all's final exam is going to be next Thursday. I think it's like the 28th, maybe. The 26th, I think. So, yeah, I think next Thursday, the 26th, will be when the final is. All right, so I'm going to stop this recording.